Let's see how we can write cosine of an inverse sine x as an algebraic expression. And the key right here is that for all the inverse trig functions, they all represent an angle. So right here, for inverse sine x, I can begin by saying that theta equals to the inverse sine x that we're dealing with. And once I have this equation, I can apply the original sign on both sides. So I can do the sign right here, and I can also apply the original sign over there. This way, I can look at this equation as sine theta equals to the original and the inverse cancel each other out. I will just have an x left right here. And based on this information, we know we can come up with a right triangle. Because in terms of a right triangle, sine of an angle, it means that we have the opposite side over the hypotenuse. So sine of an angle is equal to opposite over hypotenuse. However, here we only have x. This is not a fraction, but we can totally make this into a fraction. We can look at x as x over 1. So this way, we know the opposite side is x, and the hypotenuse is 1. And then we draw the right triangle this way. And you should just always draw the right triangle this way, so you can be more consistent. Put the right angle here, and put the angle here. And based on my angle choices, this part right here, this is going to be the opposite side, because this is away from the theta. Opposite is equal to x, so I will put the x right here. And the hypotenuse is equal to 1, which has to be the longest side, which is going to be right here, and that's 1. And I can figure out the third side that we don't know. And based on the Pythagorean theorem, I can call this to be a. We know that we must have a squared plus x squared is equal to the hypotenuse squared, which is 1 squared. And we can solve for a right here, minus x squared on both sides. So I get a squared equals to 1 squared is 1 minus x squared. And square root both sides, I get a equals to square root of 1 minus x squared. And this right here is a. I take the positive square root, okay, even though I square root both sides, but I just take the positive square root. I bring this to here, so I have 1 minus x squared. And if we go back to the original expression, we are trying to get cosine of an angle, and this angle right here is theta, is the angle right here. And we can look at this triangle, this right triangle, and do the usual cosine business. So by focusing on this triangle, and remember cosine in a right triangle, it means what? It means the adjacent side over the hypotenuse. This is the angle, so the adjacent is this part. The adjacent is this, square root of 1 minus x squared. Then you can put this down. Adjacent, which is square root of 1 minus x squared, over the hypotenuse, which is 1. And over 1 never matters. So I can just write the answer as square root of 1 minus x squared. And this right here will be cosine of inverse sine x. So this right here is how you can make cosine of inverse trig functions into an algebraic expression, just like this.